Okay, well, my laptop is with Ubuntu is still sitting here. I haven't touched it in a week and a half because of the new job and that taking up most of my time during the day, and then being completely brain dead afterwards. So I haven't felt like working on it. So that's my story. I'm sticking to it.
Okay. Um, last time I was saying I was looking at thinking about converting one of the power steering motors into a giant RC servo, and I said there's lots of places online on YouTube where people are telling you how to do this type of thing. They're all using a like a or a windshield wiper motor or a power window motor, and then basically taking the guts out of a taking the guts out of a now my color's all screwed up. Anyway, here's a board and a motor and a pot out of a just a typical RC servo. And this one, unfortunately, I have to heat up the leads on the motor to pop the motor off the board. If you get the little micro ones, those have wires on the motors and wires on the pots. But when I went to take one of those apart, I don't have a screwdriver small enough to get the screws out. And this one is one that was just laying around in a box, and I started looking at it. It's the board's really nasty. It's got big solder blobs on it, and there's like a piece of extra wire that's stuck across the resistor. So I thought, well, let's start with a brand new one. So I tore another one apart. It turns out this happened to be the exact same one like I tore apart before. And here I've taken all the gears off. You can see the pot sticking up, and then the motor is underneath of this thing here. In the back, there's the board again. So I got it this far and couldn't get it apart. And somebody says, "Oh, you just put a screwdriver, you wedge a screwdriver in between the this plastic and the gear that's in there, and there's pry the thing to get the motor to pop out." So that's how far I got on that. What was the other point on that? So I'm the point where if I hook up the wires to that, I could go ahead and test the stuff out. And I did notice on the YouTube videos they all seem to be wrong. They there's one guy that started off says, "Here's a diagram of what I'm doing," and he didn't hook up the VCC line on his power drivers. So here's one of the power driver boards modules, and this is the one that if you buy four of them, you get them for like $5.50 a piece, and it's got the I see my background's being a problem here. It's got these pins here that's like 8 pins that you can plug into. There's a VCC and a ground. There's two enable pins, and then there's a forward enable and a reverse enable. It also has current measure output if you want to try to measure the current on the thing. So anyway, they start off this diagram. They did not connect the VCC pin here on the H bridge, but it turns out since they put 5 volts on both of the enable pins, I think it's powering the board through the protection diodes of that. So it still works, but nobody seemed to be smart enough to realize that's not the way you should do it. And I was digging farther and I found another guy that he built one, and he actually hooked up the VCC pin. And but what he did was he had a separate battery. So he had his RC receiver, had a battery, the standard whatever you put on radio control receiver uh receivers. So he had that powered up. Then he had a separate battery to supply his 5 volts. So it turns out they're completely isolated. It doesn't have a common ground between the two. So that's another problem. He did hook up the VCC, but didn't have the common ground. And then I think that one works because the two wires coming off the motor on the RC servo board, typically they're both low. And then to drive one direction, you pulse one of the pins to go one direction, or you pulse the other and go the other direction. So at all times, one of those is always low. So I think that's getting its ground reference back through that, again, back to the protection diodes and so forth. So I was just going to go ahead and wire mine up correctly when I get ready to do it. And then here's the, as I say, this is what the module looks like, and it's like $5.50. And then I went through and put so on the power lead, I just found a fuse holder and put connectors. I can plug that into a lead acid battery. Then coming off the other one, I just put enough wire I could lay this on the seat and plug it in the power steering motor. And then it's my motor already has Anderson power pole connectors on, so I put those on. So basically, the high power wiring harness is done, and it's just a matter of coming into these pins and hooking up the pins there I need to run to my RC servo board or the radio control servo board. So I just got to hook them up to this board. And I was just trying to figure out, because if you put these things off long enough, you keep thinking, oh, I could do this or do this or do this. So all I want to do is just cut the wires on the pot. And that gives me 3 wires I can solder onto something else. And one of the guys was taking various wires and twisting them together and soldering them on. He had the board that was half this size, and he was trying to solder the wire onto a somewhere like here or down here. He was trying to solder the wire. And I thought, well, that's a real mess doing that. I realized if I take all my wires and twist them all together and put them outside, then I can just take these 3 little wires and solder them onto my bundle of wires. So it's not a matter of stressing the board or popping off the board or shorting anything out. So that's probably what I'll do on that. And I guess that's basically, that's the point where I'm at on that. It just simply, I just have to go do it now. I just have to hook up the wires and then take it out and verify it's going to work. So I'll have to get around and do that. I don't know how soon I'll do that, but I'd like to do it today. But I've put this off for a full week now, so it'll probably be a few more days before I get around to it. And the whole point is if you can do that, so the thing acts like a radio control servo. So basically, you just plug the cable into whatever normally runs your RC stuff. Then hopefully you can get that big motor to respond well enough that way you don't have to have a processor and you don't have to write software and you don't have to fight with that. That still might be the best way to go, but this might be a quick way to get around that. So that's why I went down this path. Any questions on that? So the other thing I did while I was ordering those power drivers, I ordered these boards. It's a little, it's like those magnetic sensors that Al is using. I don't know if it's the same number, but this is the one I was trying to look up on Amazon just before the meeting. Let focus. No.
It's
Anyway.
not focusing.
So anyway,
5600, I think, is what that one is.
Yeah, this is the 5600. And I was trying to look at them on Amazon and they were fighting me. So I can't show you the pages that they're on. But yeah, it's got an I2C interface. And it looks like it's got an output pin. And somewhere it said that can either be a voltage or a PWM. And so apparently somehow you can program this chip to make it do that. So anyway, I bought these thinking that might be handy to measure whatever. And then I started thinking about the issue of, say you want to take your lawn tractor out and verify that, if you set your transmission to a, say 50% forward and the thing's driving around on flat ground and then you drive up a hill, the argument we have to prove one way or the other is, will the governor on the engine correct for that speed, and will it maintain a constant speed whether it's going uphill or downhill? And I thought one thing that would be handy to know is if you could monitor the on the carburetor, it's got this thing that turns like this. It's got this throttle plate down here and it turns like this. And if you put something on here to see what angle that's at, because that's controlled by the governor on your engine. So typically on a lawn tractor, you set the throttle position lever on your dashboard to whatever speed you want. So you set it to 50%, that pulls against a spring, and then the spring pulls against a mechanical governor on the engine, and that runs the throttle plate on the engine. And the outcome of that is you set it to say 50%, and then it should maintain that speed if you're going uphill or downhill, or you go into deep grass or no grass or whatever. So it'd just be one more thing. You could monitor the actual throttle position of the carburetor, and then you may or may not want to monitor the position of the handle on your dashboard. It's really not important. Just set it to something. And it might be nice to know the RPM of the engine while you're doing this. All you really need to know is that if you go out in the yard and start driving by watching on, say, GPS or your back wheel odometry, you can tell how fast the thing's going. When you come to the hill, if it starts going up the hill, you can just say, does it maintain the speed? So you don't really have to put all this extra instrumentation on that I was thinking about. But that's just I was just thinking that, if you're trying to flesh out this whole thing and say, this is what I think it's going to do, and then go run it and say, here's the results I got out of it. That way you've got enough information there. You can say, this is what the engine's doing. This is what, all this stuff is doing at the same time. So you can just plot all that, just write it up and, document the fact that that's what it does. And this is how it works. And it may or may not do what I expect it to. So that would be just nice to have that information available. So I guess that's, and the other thing is just the fact that, you've got this board and you got they give you a magnet you can glue onto something. And that just simply, as the shaft turns like this, it's on the end of it here, and it just knows what angle the shaft is at. And Al is using that for various things. I think measuring his steering and measuring the rotation of his back wheels and that kind of stuff. So I thought, well, I'll just have some kicking around. So if I need to measure something without putting a mechanical load on it, that would be a handy way to do that.
How accurate is that?
I don't know. Al might know.
Crazy accurate. I mean, it's amazingly accurate.
I mean,
If
is
you
it
can,
to the
if you,
degree or 5 degrees or?
well, in a 360-degree rotation, mine is 14-bit. I think the AS 5600 might be 12-bit, right? So
I think it's 12-bit. Yes.
I think that means, is that 16,000 positions?
Okay.
4095.
Um,
That's how many positions it will report, whether or not it's that accurate as you're running. I don't know if it tells that spec or if you have to go measure it yourself or whatever.
yeah, the resolution is
Okay.
quite amazing.
And when I bought them, I think I bought 5 or 6, and they came out to like $2.50 a piece or something. So you just have to hook a I2C interface to it, or you could put it in analog voltage output mode. You could actually just measure the voltage on it too if you wanted to. So if you're trying to just measure the absolute position of one rotation, you could use the voltage. And then Al is actually lets his roll over. So he's using the I2C output on it. And when it goes from 0 to 4095, or in his case, 0 to 16384. Every time it rolls over, then apparently that will work. So he gets continuous rotation on his. So that's just another tool for the toolbox, or something to take up room in my junk box. Maybe that's what I should say. So I think that's all I got.
Well, got good news and, as typical, good news and troubling news. So out on Slack, I posted a couple of items. Why is that taking so long to load up? So that was the actual path that it ran. And that there's 1, 2, 3, 4, 5, 6, 7, 8 waypoints on that path. So good news is it achieved those points. 1, 2, 3. I don't know why that one. Oh, it's like it was. Yeah, just obviously not stellar, but it got something done, which is quite awesome. Because the amount of time that it's taken to get to this point is quite stunning. Part of the journey to get there, this is the Pure Pursuit code, and had some back and forth with Jeff on whether his code was this code that's live in rows 245 through 249. A week ago was commented out, and it relied only on this, which allowed this angular Z value to never be negative. It was always positive, because it was just going to this max, and there's one of these is velocity. Maybe it's that V. So this calculation uses velocity. So having control of your speed is really important in this particular control algorithm, which I believe is an issue for me at the moment. And let's see, where's the chart I wanted to show? Oh yeah, this is plot juggler. So my I captured the bag file from that that run. This is left speed and right speed, and then it averages those two, and so you can see the speed is terrible. It's not terrible in the sense that it's just terrible in the sense that it's up and down, and more so than the elevation of the land is. It's not perfectly flat, and it does have some angle to it, but that's not the explanation here. I was walking next to the lawnmower while it was running that path, and I could see the control arm for the transmission going periodically back and forth. And when I looked at command velocity linear X, you can see it's just flat out. All I want is a 0.7 speed, which is meant to be like 0.7 meters per second. It's not. I haven't tuned my transmission, but that's the notion is that's sort of third gear, if you will. And so it's not that command velocity. My speed variation is not because command velocity is going up and down. And the other safety feature that I have is if I lose, I can't get to that. If I lose RTK fix, I have a safety feature that says, hey, put the machine in neutral after a while. But the value of 2 here represents that it's got RTK fix, goes from -1 to 0, and then I get up to 2. And so it's the same. So my hypothesis is I have either a LoRa issue because LoRa might be dropping, because that's also a part of the safety equation, or the Servo 200 that I'm using that's connected to the transmission is rated. Well, I have hooked up on a desk check. I hooked up a fixed configuration where I had a luggage scale between, I fixed the luggage scale and then connected it to my servo with a control arm. I think it was at about 2 inches off the center of rotation, and it would pull about 40 pounds before this had some sort of overcurrent protection in it, and so it would, literally it would just give way and stop, and the arm would come back, and then maybe 2 seconds later it would engage again. So it got me thinking about whether maybe I'm kicking in that overcurrent protection, and that is probably my leading hypothesis at the moment versus the LoRa thing. This spreadsheet is just me doing a few calculations with my center of rotation about 2 inches away from the mounting point. Theoretically at 12 volts, it's going to give me about 40 pounds of torque, which is again about what the transmission requires in order to be able to move that control arm. So this calculation suggests, if I wanted a little bit of headroom, so to speak, I need to move that control arm down to about 1 1/4, or if I wanted a 70-degree movement. If I really, ultimately, I might use this calculation because if I can squeeze it in, I think to go full forward is about 1.5 inches on the hydrostatic transmission, and full reverse, I think, is about 1 inch. So that gives you, let's just say 2.5 inches and make it 2 3/4. I could get, and I don't want to do a full 180 rotation because I'm nervous that, once it gets down to 170 degrees or something, it might lock up or something. So if I just limit it to 160 degrees rotation, and I'm 1 inch off of the center of rotation, long story short, I think I can get close to 80 pounds of torque, which would be well within that. So that's my next step, is to disconnect transmission, servo, change the mounting point to the center of rotation so I can get some consistent speed, and then test again and see if that, well, and in addition to that, write a program to publish my LoRa status, because I don't have LoRa status in my bag file, so I can't really check post-test whether or not my LoRa was failing. But the more I think about it, the more I think it's my transmission or super servo over over current, I guess is probably more accurate. Over current protection kicking in. That's what I got.
You have a way to monitor what you're telling the servo to do? I assume you're putting out a RC PWM to run the servo. Do you have a way to log that? Is that in your bag file? You can see what you're actually telling it to do?
No, it's not in the bag file. I thought it was going to be in the bag file, but since I switched from ROS serial to my, I haven't published that in a topic. I publish it on the screen, and so it's in standard out, or the console. And so if I took a video of the screen, I would have it, but I have to have to write a publishing topic so that I can see that.
On that note, you can probably, when you start your launch file, just say redirect that to a file, so everything shows up on the screen gets recorded to a file while it's running. That way you don't have to do anything other than tell it to do that when you start it. And that way if it's showing up on the screen anyway, then you can go back and it'll be in that file. There's some trick. There's some trick. If you say redirect it to a file, you won't get anything on the screen. But there's another trick. You can say there's something like you put it like a %1 or something, and then it puts it on the screen and puts it into a file, I think. So that'd be a quick way, around that. If you don't need to see it on the screen, just say, start your launch file and say redirect to a file, and it'll take all this data that's coming up on the screen and put it in a file for you.
So that output, this is a node that reads the serial data and outputs it. Right now it's just screen. So you're saying there is some, if I put a file name there, it'll all go there?
No, I'm saying when you execute this launch file, where you say ROS launch this file, then at the end of the line, just put a greater than and a file name, and anything that comes up on the screen automatically gets recorded to a file. So you don't have to change any of this stuff.
Cool.
But it'd be very good to know if you are telling that servo to do something funny, instead of guessing that, well, maybe it's current or with something else, look to see if you're actually telling it. If you're telling it a constant speed or a constant position and it's changing, well, then yeah, it's probably something mechanical or over current or whatever. But if your code is telling it to change speed for whatever reason, then that's going to save you a lot of time instead of trying to track down all this other stuff. If it says I am telling it the wrong thing, and you can back up through your steps and find out, is it because the radio is telling it to do that? Is because whatever. So that'd be a good thing to to nail that down ahead of time, to know where that's coming from.
Yeah, that's great input. Thank you.
And then back, you're showing the the thing about you got the 8 points that you've defined. Well, keep in mind, pure pursuit is not expecting that. Pure pursuit is expecting you to put all the points on that line, and it will follow those. So that's like just saying, well, I'm just going to specify a point on the other side of my yard and expect it to follow some well-defined path, when in reality it's just going to try to get to that point. So either you could just put extra points in there, or go back and go back to the Dubin's path generator, and put your points there and let it generate the points for you. That way it'd be less painful that way. You can still put your eight waypoints into the Dubin's path planner program, and then it'll spit out this path. It'll have all the points in that you need. I think there's something else too. Oh, the other thing is, you may want to look at, again, depending, you may not have, you're saying you switch from ROS serial to something else, so you may not have this, but I would like to see you print out the command velocity and print out the Ackerman and compare those, because that command velocity you're using is not steering angles. So it would be good to know what you're trying to get this thing to stay on your path, which it doesn't have a path. It's, you've just got the endpoints. But anyway, if you could do that, if you could get the Ackerman, get the actual thing that it thinks is steering angle out of that, it would be to your advantage.
These are the, well, I mean, I can go back to this. Which of the topics are you interested in? Or where is the Ackerman thing?
Probably called Ackerman command or something. It's the,
There's Ackerman in, Ackerman drive stamped.
that might be it. That might be that stuff that I was doing to. Are you running any part of the simulator at this point while you're driving the thing out in the yard? I know you said you were going to do that.
No, my launch file is
So I'm thinking that Ackerman in is probably where I was converting the output of Tab Planner, and then I was converting it. I was just changing it from one, either a stamped or non-stamped message. That might be where that's coming from.
yeah, I've got Pure Pursuit running, I've got RViz running. The only thing I'm still a little fuzzy on is this Ackerman controller.py and this controller manager, but I'm not running Gazebo, if that's what you're, if that's
We
the,
probably should not be running Ackerman controller.py, because that's strictly for the simulator. I don't think it's going to hurt anything at this point. It's just generating wheel angles for you that you're not going to use for anything, but you don't need to have that in there if you're not running the simulator.
so
But if you look at the actual Pure Pursuit, it puts out that command velocity, and it puts out some kind of Ackerman message. And that's the one I'm talking about. And back to the point you're saying that right here about the code being commented out or not. My guess is that somebody, as an afterthought, added this, said, let's put out command velocity in addition to this Ackerman message that we're putting out. And I'm guessing the reason that's not right is because they just didn't test it. They put it in there thinking, okay, that'll solve all of our problems. I'm guessing nobody's using that, is why you had to modify that.
So let's try to find what topic here. So where's I'm looking for the statement that'll tell me what that looks like in the ROS topic list. The advertise.
It's probably right there. So it's either going to be, it's probably going to be called Command Acker. When you're running, I think that's what it's going to publish.
Yeah, why is that not in my bag file?
Well, you said you switched from ROS serial to your own publishing stuff. If you're not passing that through, you just may not. You may be ignoring it.
Turn it off. And I did a ROS a bag file all. Hmm.
Well, I guess if that's running under ROS, yes. If you say record everything, that should be showing up there. So, because that's not going back and forth to your vehicle. I can say, well, maybe in a parameter you rename that to something else, but I see it
Oh, yeah,
down there.
it is.
Yeah, right there. It's you called that Acker in, so that might actually be the thing you're looking for.
Oh, come on, stop. What is in this that you want to see?
Open up Drive there and look at steering angle. Plot steering angle. And if you plot that against your value from command velocity, which is rotational velocity. So this is going to be the requested steering angle for your steering.
You mean angular Z?
I'm going to say yes.
So purple is angular Z and blue is Acker in steering angle.
And the other thing I noticed last time you're going through your configuration file and it said set something about the rotational velocity, said set that to 0.785. Another one that said set steering angle to 0.785. I'm thinking the one that says steering angle is going to be used in the Ackerman calculation, and the one that said something about that file right there. What those says? There's one that says steering angle limit, one says max rotational velocity. So I'm guessing the one that says max rotational velocity is going to be used to convert or create that command velocity message. And then wheelbase and maximum or steering angle limit are going to be used to calculate the Ackerman steering angle. But it's the steering angle is what you really want. You don't want the rotational velocity out of command velocity, which is what you're using.
Why don't I want command velocity?
Because that's rotational velocity and that's not steering angle. Unless you have some way to convert that. Because you have to take rotational velocity, you have to take your wheelbase, you have to take your what's the other thing that's involved there? You have to take your forward speed, and then you have to do a couple calculations, take the arc tangent of that, and that's what's coming out as steering angle.
What's intriguing is that's
Right there, that rotational velocity being clipped at your 0.785. And then the steering angle is going beyond that. You're getting, you can see it's actually responding and giving you steering angles down there, which are greater than the 0.75. So I don't know exactly how it controls that, but
I don't know what I would do with a steering angle of negative 1.5.
that's too big a number because you want, I thought by that parameter file I was going to clip that at 0.75, but it apparently is not doing that. So you'd have to look at those numbers some more to see what it's actually doing there.
Hmm. Well, that's input
fr-
to,
And from your graph right there, you've either got 0 or you got 0.75 on your rotational velocity that's coming out of the thing, which is probably, I was gonna say it's probably not what you want, but maybe that would be valid if you're saying, if you're going straight and you say turn to the left, it's just going to turn it as hard as it can. So maybe that's why it's doing that. But the point is, rotational velocity and steering angle are not the same thing.
um, yeah, that is a weird. When the off-path error is obviously varies. I'm perplexed why that is such a fixed value. It's either, mostly it's 0.75, or in the case of angular Z and minus 1.2. There's like no variation in this. That's a head scratcher. I would have thought that number would vary, either one more than it is. Hmm.
It could be those parameters in that parameter file aren't doing what you think they are, because when you run your launch file, you can also overwrite those with some other numbers. So it'd be good to figure out, which set of numbers is actually being used there. Since the steering angle, I thought it said it was the limit was set to 0.75, yet it was giving you a 1.5. That leads me to believe that number's not being used. That limit's not being honored. So in line 6, where it says steering angle limit is 0.75, yet the plot was showing 1.5. It just seems like possibly in your launch file, it's either setting the parameter there, or this just isn't working. So it doesn't look like there's anything there that's affecting those, but what's that right below where it says speed parameter? What are those values?
Those are my, call them presets for my servo transmission. So this is
Oh, okay.
neutral, first gear, second gear, third gear, fourth gear, full reverse, half reverse. Now, more to ponder. That's all I've got.
I went through that thing. I took that extra helper routine from the TEB planner where it converts rotational velocity into steering angle. And then I went through and tried to reverse calculate, so I can say, because normally you put in forward speed and rotational velocity, and then you have to tell it what's the wheelbase of your vehicle. And I was thinking there might be one more parameter, and it does some calculation that spits out a steering angle. And I thought, well, what if you want to go the other direction and say, your steering angle, what's the rotational velocity? So I tried to uh, tried to use some basic algebra and solve for one case I solved for steering I'll solve for rotational velocity one time, and then I think I solved for the forward speed or something. So I just tried to get to the point where I could, go back and forth on that and figure out what's going on. Because the other thing they do is the first thing they do is if you take forward velocity divided by rotational velocity, that gives you the radius of the curve you're going to go in. Yes.
Yes, I have to get ready for another meeting, so I will bow out, but I look forward to watching the rest of the video.
Okay. So anyway, I just went through the trouble of trying to do something with that, and it's on my other computer. I could post it right now. I could post it to Slack, I guess. Just say, here's what I came up with, and maybe with a little more explanation, or just post whatever I had there.
Yeah, it would be interesting to see no matter. Because at some point I'm going to get this speed thing worked out, and then it's going to have something more stable. And then we'll be down to what's this thing calculating.
And it may be worth the trouble to say, put in one of those Dubin's path, create a path with that Dubin's generator. And so you got the extra intermediate points. So it's actually trying to follow along a line, a predefined line, as opposed to just going off to a corner point somewhere. That might, number one, it's going to constrain it. So you're not trying to do it as wild of things as it was bouncing back and forth like that. So if it's actually trying to stay on a line that's, a point that's say 4 inches out in front of you, try to steer to that might calm it down a little bit too by doing that. That's not
Yeah,
that's not going to fix your transmission problem, but that's just for driving around, that might help.
Yeah, I have the same basic path using Dubin's. And so trying to replicate that by hand, I was just thinking it would be complicated to figure out, well, which point is it actually trying to get to, because there's so many that it's processing. So I can run either one.
And one more point, you pulled up a plot that said off path error. Keep in mind, I don't think the off path error actually means how far is your vehicle off the path. I think that's an internal calculation that they're trying to figure out by taking where you are and looking at the next point, which happens to be 20 feet away when it's expecting to be like 4 inches away. The fact it's called off path error, I don't think it may not mean what you think it does.
Okay.
So don't put a lot of faith into that, but
I was just assuming it was the distance from the theoretical line between the 2 points it was leaving from and going to.
that's what I originally thought it was too. But when I went and looked at it, I don't think that's what that actually is. It's just unfortunate that what they called it leads you to believe it's something else. I might be wrong on that, but I do know at one point Matt had modified that, so he's publishing that number, and I was thinking, well, that number doesn't look right when I graphed it, and that's when I realized that, well, maybe it's not, doesn't mean what people thinks it means. So that's just something to keep in mind.
Good deal. I think that's all I got.
Yeah, I think that's all I got too.